summation under electrode. Summation of each action potential. But on the distance between stimulatory electrodes and record electrodes, distance, for example, 40 centimeters. This action potential converts to several peaks. It becomes this, like this. Why?
Because there are space between them.
Speed and we have distance, and when action potential is propagated,
the charge will be less. The charge will be less according to the way to transfer the next cell.
I don't understand a little. Your idea, why? What is about value of speed, velocity, velocity of action potential propagation? Is it equal in each nerve fiber or different? Equal, the same or different in different nerve fibers? Different. Nerve includes fast nerve fibers with fast propagation, rapid propagation, with medium velocity and slow velocity. So fast fiber propagates action potential faster, solitary, and we have first peak.
Like C? Like C?
What is the name of fastest?
C?
No, CC slowest.
A.
Alpha. Alpha because first group was called alpha fiber. A fiber.
90 millivolt?
Alpha next.
90
Bit.
millivolt?
No, it's about velocity. Velocity is measured meter per second. And velocity of action potential propagation in A fiber alpha about 120 meter per second. Meter per second. For example, from spinal cord to the muscle. Motor neuron of spinal cord has A alpha fibers and propagates action potential with fastest velocity, highest velocity, to provoke muscle contraction, rapid muscle contraction, and to run, for example. Alpha next letter, Greek alphabet.
Beta.
Next.
Gamma.
Gamma next. Delta.
Delta.
Next group B, the last
C.
C.
C fiber has lowest speed, lowest velocity, about 0.5 until 3 meter per second. You can copy my picture to understand the principle. Conclusion. Nerve consists of nerve fibers, different types of nerve fibers with different velocity, action potential propagation. Fastest A group, the most fast A alpha, and slowest propagation in C fibers, C type fibers. Next classification nerve fibers to two principal groups in accordance with structure, with presence of myelin sheath. So nerve fibers can be classified to unmyelinated and unmyelinated histology. Nerve fibers myelin sheath. Myelin sheath is formed by special glia or glial cells called sheath. Sheath is covered. Myelin sheath is formed in ontogenesis with by special glial cells, oligodendrocytes in the brain, or they can be called Schwann cells in the peripheral nervous system. The same cells but different. And myelin sheath is formed with many layers, with one cell, oligodendrocyte or Schwann cells, form cyclic covering, layer by layer. But between two adjacent newborn oligodendrocytes, they have empty space, free space. It's called ranvier. No.
گره رانویه میده.
Ranvier. No.
گره رانویه
Ranvier. No. Ranvier. No.
از میلینا میپریدم. آره میلینا نمیومدم سمت میلینا.
It's responsible for recovering the
Yes.
اون گره رانویه ایجاد میشه. گره رانویه ایجاد میشه.
Yes, and it has to be there are spaces between every two cells.
Between two cells
Yes.
in an empty space.
Antimyelin is responsible for regeneration.
Myelin sheath has many functions. The functions are trophic function to supply nerve fibers with lipids, proteins, to provide reconstruction of membrane, renewal membrane, glycoproteins, glycolipids, polysaccharide, and second function to provide high electrical resistance. Do you know physics? Resistance. So this part with myelin sheath has have high electrical resistance. No, what my picture, it's a contrary word, second variant. This is a scheme of myelin sheath, myelin, and empty space,
Ranvier.
not.
We say گره رانویه.
Correct. Shit.
مال من همه گزینه‌ای بودن. نداشتی ولی.
Shit with A or B, without, no, not important. I don't remember. What is the difference in propagation of action potential? There are two functions of myelin sheath. The first function, trophic function, protective also. Second function, protective, mechanical protection.
Make rapid condition. Make rapid condition, like fast condition.
And facilitate.
Just only in A and B. Cells A and B.
RNP, do you mean?
Yes.
It can change RNP to action potential. What do you mean? Electrical properties or physical properties?
Myelin sheath. Myelin sheath.
Yes, and
Yes, it's just only in A cells and B cells.
what nerve type? What fiber from then myelinated.
Yes.
A and B. C unmyelinated. It's very important to provide required speed of action potential propagation. What fiber, unmyelinated or myelinated, has faster propagation?
Myelinated faster.
Myelinated. We must understand why. Resting membrane potential, or when membrane at rest, what charge is outside?
Plus. And in minus.
Inside net.
Minus.
With stimulation by or threshold stimulus, we evoke action potential. What happens during overshoot? Outside. What happens? Negative. Becomes negative. Due to reversal. Reversal. So we have outside difference in potentials between excited part and resting part. On both outside and inside. We have difference of potential. So we have electrical current. What is the source of electrical current in living tissue? Electrons or ions? Ions. Positive ions, potassium or sodium. So we must mark direction of electrical current with arrow from positive to negative. So the difference of potential forms electrical currents with enough force, enough intensity to stimulate adjacent part, the adjacent parts until threshold, to depolarize until threshold, and evoke new action potential on the adjacent part due to electrical currents. And action potential becomes being propagated. Why it happens to both sides? Because it's not important for current in isolated neuron. Now I explain on isolated neuron. In a real neuron, we have a little another situation. Because only first segment of axon has the highest excitability and its primary site to evoke action potential. And then action potential propagated to synaptic ending, synaptic bulb. Action potential cannot be propagated to the body or propagated a little because body has high electrical resistance. Here we have the equal electrical resistance on both adjacent parts. So in this case, not important. If you apply electrodes, stimulating electrode on the skin and stimulate it, you have this situation, and one signal will be propagated to muscle directly, and second signal will be propagated to the central nervous system, to the neuron body. If you apply here stimulation, one signal will be propagated again in the same direction and provoke, for example, muscle contraction, and second action potential equally will be propagated to the body. In the artificial stimulation. But in the real system, we have propagation from the body to it's called bidirectional propagation. Bidirectional. And it happens from point to point, more or less slowly. It's called continuous propagation. Continuous. Continuous propagation. From point to point. Point by point. What happens in myelin nerve fibers? Initial mechanism the same. Resting state, rest parts, excited parts with action potential, the same. And again we have electrical currents between excited part and resting part. Ranvier not contain mostly sodium voltage gated channels. My question is second variant. No? What is a channels? Voltage gated sodium channels. Is a special property. Ranvier not contain mostly voltage gated sodium channels. They are more important to evoke action potential, depolarization phase. And it increases excitability of Ranvier not. There's excitability here higher due to high concentration of sodium voltage gated voltage gated channels. Where are potassium voltage gated channel located? Mostly near under myelin sheath. It's special knowledge, not important for us. Ranvier not contains more sodium, mostly sodium voltage gated channel with high sensitivity of gate to stimulation, to electrical current. So myelin sheath part cannot respond with action potential because it has high electrical resistance. High resistance. Impossible to excite nerve fibers inside, under myelin sheath. So necessary excite to at adjacent Ranvier not, next Ranvier not, and action potential, next action potential will be evoked only just Ranvier not. With the same amplitude. So action potential is propagated in myelin fibers from one Ranvier node to the next Ranvier node. What is the name of this propagation? Jumping saltatory. Saltatory propagation by jumping. It's a faster option to propagate action potential. With damage of myelin sheath, for example, some types of sclerosis, autoimmune, usually commonly autoimmune disease with damage of myelin sheath by our proper immune system, autoimmune disease. When our immune system produces antibody to our proper proteins. Proteins myelin sheath, it destroys myelin sheath, and speed of action potential propagation becomes slower. It destroys many functions of nervous system. We will study it later in the next unit. Well, what more? What are the main laws of action potential propagation in nerve, along nerve? At first, bidirectional propagation from the point of stimulation. Next, isolated propagation. Can one action potential be transmitted to the adjacent nerve fibers? To jump from one nerve fibers to the next. Is it possible or not? Action potential propagation between two nerve fibers inside one nerve. Is it possible or not? It's possible, no? Because it would destroy function of nerve. Each nerve fibers propagates action potential without transmission, direct transmission to adjacent nerve fibers. Why? Due to glia cells, myelin sheath, and another cells surrounding nerve fibers. If you can transect this transection of nerve, you can see histology. Some unmyelinated nerve fibers and myelinated. Did you study histology nerve histology? Did you study?
No. Just epithelium.
It's about for me. I must set your picture. There's a transection nerve, controversial transection, and you can see some fibers unmyelinated and myelinated. It's slice. Myelin sheath with many layers, providing high electrical resistance, and unmyelinated. But between myelinated, again, we have glia cells. It's isolation. It prevents jumping of action potential between two nerve fibers inside the nerve.
What is their name? What is their name? Which program?
Glia cells between nerve fibers to provide isolation, like electrical cable. Electrical cable contains many small metallic, but each cable, small cable, is isolated. Which isolation bidirectional and absence of damage. Each damage, mechanical damage, thermic, for example, cold or high heating damage, anesthetic, chemical damage, decreases speed of action potential propagation or make it impossible. This nerve must have physiological and morphological normal condition. Why? This is an interesting question. Why action potential, for example, new action, green action potential cannot return to previous path? This action potential propagated to both sides from the point of stimulation, but it cannot be returned to previous side. Why? It's impossible. Action potential runs afar, and then it's possible come back.
Maybe this is the center from the beginning of the circulation.
But again, we can have difference of potentials. Here, for example, we have again reversal minus 5. Here repolarization and restore membrane potential. So again, electrical current, but this electrical current cannot excite previous path. Why?
Because when it's in action potential is in the resting potential, so the next one is in the action and the resting.
But with physical, it's obviously for us, but what is the physics nature? Here reversal, here repolarization. We can have electrical current, but this electrical current cannot evoke here now because it affects, for example, during this phase. What is excitability during repolarization? Previous class. Excitability. The характеризирует.
Open gated channel potassium.
And what is about excitability?
Repolarization.
Refractory period, relative or absolute relative refractory period. Action, action potential cannot come back to previous site. Action potential cannot come back to previous site due to refractory periods. Action potential cannot